Hello, Science Tutor Online here, and we're looking at a gecko climbing up a pane of glass. Now the reason they're able to do this is because of what's known as the van der Waals interactions. It's a kind of weak chemical bond, and it's one of several chemical bonds we'll be looking at today. Now if you're not already familiar with electron shells and orbitals, you may want to watch my other video first. It's called Orbitals and Energy Level Basics. You'll find it on YouTube. Or better yet, if you're on my website, just go down beneath this video and you'll find a link there. And that said, let's get started. Now you remember that an atom consists of these positively charged particles called protons and also a neutral particle called a neutron. So these protons and neutrons make up the nucleus, and they in turn are circled by these little tiny particles known as electrons. And just remember, the proton has a positive charge, the neutron has no charge, and the electron actually has a negative charge. Now remember also that electrons follow these patterns called orbitals, which generally just describe where the electron is most likely to be found 90% of the time. And depending on how many electrons there are and some other characteristics, the electrons will fill up one or more electron shells, which each can hold a fixed number of electrons. So you've got your nucleus here. Let me give that a different color. Let's say you've got the nucleus of the atom. You've got electrons circling around it in a shell. Now the electrons will tend to fill up the innermost electron shells first. If this is the lowest energy level, think of the analogy of the parking lot, where of course the parking spaces closest to the stores get filled up first. However, for chemical reactions and chemical bonds, we are far more interested in what's happening in the outermost electron shell, because this is what determines the kinds of chemical bonds that can take place. The electrons in this outermost shell are known as the valence electrons, and that's going to be very important in just a moment. So valence electrons are the ones in the outermost shell. Now here's where things get interesting. There can be a fixed number of electrons in any given shell. However, the number of electrons will normally balance the number of protons that are in the nucleus. And so this creates a situation where maybe the outermost shell can hold 8 electrons, but because there are fewer electrons, because the electrons need to balance the number of protons that are in the nucleus, there may actually only be 4 electrons out here. 1, 2, 3, and 4. And in fact, this is the case, for example, with a carbon atom. So carbon has an electron, its outermost electron shell can hold 8 electrons, so we'll say 8 possible. However, to balance the positive and negative charge, carbon only has 4 electrons in its outer shell. Now what this means is that there's like a space or hole for up to 4 electrons to be added to the carbon molecule, or those final 4 could be stripped away from the carbon. And this means carbon has a valence of 4, as we say. This means carbon has 4 empty spaces that can be filled up by additional electrons from another atom. And in fact, this makes carbon very versatile, and it's the reason carbon is basic to many important chemicals and processes in life, such as carbohydrates and amino acids. Now let's look at how some of these bonds work. So let's say we've got our carbon atom, and in its innermost shell, the first shell, it's got 2 electrons. Okay. Then in the next shell, carbon, as we said, it can hold up to 8. However, normally it only has 1, 2, 3, 4. Now this allows carbon to bond with other molecules. Let's say we've got a hydrogen atom over here, and the hydrogen also has 1 electron. But now watch, when the hydrogen approaches the carbon, it has its own electron, and that individual electron from the hydrogen is going to fill up one of the holes. So now this carbon has 1, 2, 3, 4, 5 electrons in its outermost shell. Remember, it can hold a total of 8. Now here comes another hydrogen over here. Now the carbon's outermost shell is filled up. It's got 1, 2, 3, 4, 5, 6, 7, 8. A total of 8 electrons in its outermost shell. So it is now filled. And it's basically, essentially, it's shared its valence with the hydrogen. And so we say this bond that carbon is made with these hydrogen atoms is a covalent bond. A covalent bond because the carbon shared its valence with the hydrogen. So valence is shared. And by the way, for those of you who are a little paying attention, we now have CH4 here. This is a methane molecule, so CH4. And methane is created as a result of carbon forming covalent bonds with 4 hydrogen atoms. So we've got our carbon in the middle, 4 hydrogen. Now before we get to the next step, we need to cover an important concept here. We've got a number of protons in our nucleus and a certain number of electrons in the outer shells. Suppose the charges don't balance up. Let's say we're short a few electrons so that there's a net positive charge. And if we have 5 protons and 5 electrons, the charges are balanced. If we've got 5 protons but only 4 electrons, then we've got a net positive charge. And this is where things get confusing. Because it's a positive charge, it will attract more electrons, and this means that this atom is electronegative. An electronegative atom is one which will actually attract more electrons to itself. And this is also an important process in a lot of chemical reactions that are important to life and biology. For example, oxygen is very electronegative. What this means is that oxygen tends to attract electrons from other atoms. In fact, it often strips them away. And when this happens, when an electron is being pulled away from another atom, we say that that atom is being oxidized. Now, by contrast, if electrons are added to an atom, so we have our atom over here, we have electrons, it's attracting electrons, and electrons are being added to the atom, we say that this atom is being reduced. When something is oxidized, it's losing electrons. When it is reduced, it's gaining electrons. And these combinations, we call it, think about reduction and oxidization together. We get the word redox, and redox reactions are very important to life. Redox reactions play a lot of important roles in metabolism, photosynthesis, and a number of important biological processes. Now, this whole idea of oxidization and reduction is just important for getting to another type of chemical bond. So one example that you're probably familiar with is sodium and chlorine. So sodium actually only has 1 electron in its outer shell. And chlorine actually has a little hole, a space for 1. And so when sodium and chlorine encounter each other, sodium's going to actually the chlorine is going to oxidize the sodium, which means that this little electron in the sodium gets donated and goes over into the chlorine. And so sodium has just been oxidized and chlorine has been reduced because it gains an electron. And now something interesting happens. Chlorine, we now have Cl minus because it's gotten that extra electron, so now the chlorine is negative and we call it chloride. The other thing is, now that sodium has lost an atom, sodium is now positive, Na+. I'm sorry, it hasn't lost an atom, sodium has lost an electron, therefore it's plus. So now we've got a positive charge and a negative charge, and so these two atoms now attract each other very strongly. So they form a bond, and this type of bond is known as an ionic bond. We have atoms or molecules with a net positive or net negative charge are known as ions. So now I have a Na plus, it's a positive or cation. The chloride is an anion. And a cation and anion, they form a bond because the positive and negative charges cause them to be attracted to one another. This makes them form a strong bond known as an ionic bond. Now, the ionic bonds have some special characteristics that covalent bonds don't. This makes this a very strong bond when it's dry. But you know what happens when you put salt in water? It dissolves. And in that case, the water actually interferes with the positive and negative attraction because water has its own positive and negative attractions that we'll get into later. Ions that are connected by an ionic bond are known as salts. You've surely heard of H2O, which is water. So we've got our oxygen molecule O and our two little hydrogen atoms. We've got our oxygen atom, O, and our two hydrogen atoms, H and H. Now remember, hydrogen has two electrons, but remember that oxygen is very electronegative. That means it tends to attract the electrons to itself. What this does is it creates this interesting process where all the electrons of the hydrogen tend to be drawn towards the oxygen. And that means that on the part of the hydrogen atom that's away from the oxygen, there's a very weak partial positive force. The electrons are towards the oxygen atom, which means there's a very weak negative force over here and a very weak positive force over here. This isn't exactly an entire positive charge. It's like a piece of a charge. But this takes place in a lot of other molecules containing hydrogen. And in effect, there's a net positive charge sometimes around molecules that contain hydrogen, and also a negative charge on parts of these molecules. And this allows them to stick together temporarily or very weakly. Let's take a look at an example. If we have a DNA molecule, we've got the backbone here of phosphate and sugar, and these are very strong molecules. These are very strong bonds. However, in the middle of the DNA, you've got, of course, your pyrimidines and purines connected, and this middle bond is a hydrogen bond. So on a DNA molecule, essentially you've got the backbone that has a very strong bond, and the hydrogen bond in the middle is very weak. And of course, this makes it possible for DNA or even bits of DNA to very quickly split in half, forming templates to create RNA or to create new DNA and help and replicate DNA. So the hydrogen bonds, which are just created by a net positive or negative charge in parts of an atom, allow many great things to happen, such as hydrogen bonds that allow DNA to connect and separate, or zip and unzip. Now there's one last thing to consider, and this is for any kind of atom you're working with. It doesn't matter. Remember, the movement of electrons is random. The orbitals that we describe are really just places where the electron hangs out 90% of the time. But it's very possible for, just by random chance, for several of the electrons to all be in one spot. And this will create a net negative charge on one part of the atom and a net positive charge on the other, similar to what we described with the hydrogen bonds. If you've got a lot of atoms doing this simultaneously, it can actually create a fairly strong attraction. And this is known as the Van der Waals Effect, or the Van der Waals Interaction, when just by random chance the electrons concentrate in one spot, creating a negative charge on part of the atom and a positive charge somewhere else. And if you've got enough atoms with a lot of surface area, this can actually cause something to stick. And this is how our old friend the gecko manages to stick to the wall, as we mentioned at the beginning of this video.